Welcome to The Explainer. Today we're diving straight into what is honestly a massive, fundamental shift in how we actually build software. We're going to be looking at this through the lens of Dr. Ariane Hosseini's incredible book, 50 AI Workflows for Engineers. Look, if you're currently using AI just to generate a few lines of boilerplate code here and there, you're kind of missing the bigger picture. We're going to explore how AI is shifting from being just a basic, glorified autocomplete tool into a true, fully fledged junior engineering partner that sits right alongside you.
Okay, let's dive into this with a really great story right from the author. So, Dr. Hosseini shipped his first AI-assisted code back in 2023. It was a pretty simple retry handler for a notification service. Now, normally writing that from scratch, double-checking the syntax, testing it, that would take him about 45 minutes. But using AI, it took exactly 15 minutes. And what's absolutely crucial here is what he did with those saved 30 minutes. He didn't just, log off early and go grab a coffee. He redirected that exact time to write better tests, update the internal documentation, and actually sit back and think about whether the whole retry strategy even made sense in the first place. Ultimately, AI doesn't replace the thinking. It compresses the mechanical parts so you have way more time for the actual thinking.
Before we get totally carried away, though, we really need to set some ground rules. We have to establish the boundaries. AI's absolute superpower is execution. It is phenomenal at tasks where the goal is crystal clear and all the context is right there in the text. Things like parsing a massive stack trace, summarizing a legacy codebase, or just generating text. But where you, the human engineer, still completely lead is in judgment. I mean, AI doesn't know that your team has an unwritten rule about never ever touching the billing module without Sarah's review, right? It doesn't know the VP already totally rejected a microservices architecture last quarter. Social context, legacy system constraints, organizational politics, all of that is entirely your domain.
So here's our roadmap for the explainer today. First, we'll look at the human plus AI stack. Second, automating daily tasks. Third, systematic debugging. Fourth, complex system design. And finally, we'll wrap up by building your own personal AI assistant.
All right, Section 1, automating daily tasks. Basically, attacking the lowest hanging fruit. Look, as any working developer knows, a massive chunk of your week isn't actually lost to writing bad code. It's lost to messy, vague tasks and constant, exhausting context switching. And that brings us to the absolute bane of every engineer's existence. What is the real cost of vague tickets? Just picture this. It's Monday morning, you open Jira, and you're assigned a ticket that simply says, "Improve search performance." No target latency, no mention of which specific endpoint is slow, literally zero context, just 3 words. Usually, you lose the entire first hour of your day just hunting down the product manager on Slack to figure out what on earth this actually means.
And the metrics here, they absolutely speak for themselves. Before AI, processing a vague ticket like that involves relentless Slack hunting and pure detective work, costing you easily 1 to 3 hours. After AI, it's down to 15 minutes using structured context prompting. This represents a massive, game-changing reduction in the engineering tax you pay just to understand your assignment, all before you've written a single line of code.
So here's the exact workflow to literally buy your time back. Step 1, gather up all your raw context. The sparse Jira ticket, any related Slack threads, your own internal wiki docs. You can do this in under 2 minutes. Step 2, feed it all into a single structured prompt. Step 3, ask the AI for clarifying questions and a drafted implementation plan. Now, a quick reality check, and you really need to be careful here. AI models absolutely love to overscope. If you aren't careful, the AI will confidently suggest an implementation plan that involves redesigning your entire database architecture just for a simple bug fix. You have to add strict constraints like, hey, keep this to a 3-day fix to keep the AI grounded.
Moving right along to Section 2, systematic AI-powered debugging. We're escalating the stakes to the unknown.
So we're moving from the daily grind into the total unknown. Debugging is notoriously difficult because humans are actually pretty slow at reading massive amounts of dense context quickly. But think about it, debugging is essentially just pattern matching and hypothesis generation, which is exactly where AI excels. Just picture this number for a second. 147. That is exactly how many lines long a stack trace was when the author was paged at 1 a.m. for a crashed image processing pipeline. When you are staring at a 147-line wall of text at 1 a.m., and it's mostly filled with deep framework internals, your human pattern matching is at its absolute worst. You're just desperately searching for the 3 lines of your own code that actually matter. Well, AI can parse those dense framework internals instantly and point you exactly to the boundary where your code failed.
So the crucial point is, you have to follow a strict system here. Here is the 5-step debugging workflow. You gather the full context, the stack trace, recent deploys, environment details. Then you don't just lazily ask what's wrong, you ask the AI for its top 5 ranked hypotheses, and crucially you request verification steps for each one to actually prove or disprove them. You map that trace back to your actual code base. And the absolute golden rule here, never, ever change behavior without verifying the hypothesis first. The AI is giving you clues, guys, not guaranteed fixes.
And look, this is not just theoretical. There was this real-world 3 a.m. incident over at Comcast where a live TV anomaly detector was throwing hundreds of false positive alerts across multiple broadcast channels. Humans were frantically trying to read dashboards and correlate messy logs. The author just fed the logs and the alert text into an AI. In under a minute, the AI correlated the signals and hypothesized that a recent deploy had aggressively changed a timing threshold for the caption detector. A single, simple configuration change resolved the whole thing. The AI correlated those complex signals infinitely faster than a tired human could ever read the dashboards.
Okay, Section 3, Accelerating Complex System Design. We're zooming way out to the architecture level now.
This right here is how senior engineers are actually using AI. The abstractions are higher, the stakes are much, much larger, and the workflows completely change. Enter the rubber duck that talks back. See, junior engineers ask AI to solve problems. Senior engineers do not. Senior engineers use AI as a conversational partner to organize their own thinking and pressure test their ideas. It's the classic rubber duck debugging method we all know, but this duck actively challenges your assumptions and points out the glaring blind spots you missed.
So, how exactly does this work in practice for system design? Well, first you feed it your requirements, but you absolutely must include your technical context. You have to tell it things like, hey, we are a team of 3 engineers and we only have 6 weeks. Second, you ask it to outline the core components, the data flow, and the MVP scope. And finally, you challenge its decisions. If it suggests an SQS message queue but your team already heavily uses Redis, you push back and ask it to compare the trade-offs of using Redis instead. You make the final call. The AI is literally just laying out the chessboard for you.
Now, a huge word of warning here, aspirational scale versus actual scale. If you don't constrain the AI, it will always, and I mean always, confidently suggest an aspirational production-grade microservices architecture built for millions of concurrent users. But if you're just building an MVP for like 500 internal users, that massive architecture will completely crush your small team. Always, always force the AI to design for your actual current numbers and your existing tech stack.
Which brings us to Section 4, your personal AI assistant. This is the ultimate systemic integration. This is where you shift away from just opening a random browser tab to use a generic chatbot to actually building a persistent, highly informed digital colleague that lives right where you work. Let's move to and see how this builds into a real system. Step 1. Choose a base tool. Get this set up either right in your IDE or your terminal. Step 2 is the absolute highest leverage setup you can do. Configure a persistent context file. This is just a simple markdown file that tells the AI your specific project stack, your team's naming conventions, and recent architectural decisions, so you never have to repeat yourself over and over. Step 3, give it tool access to read your files and eventually to run your tests. And Step 4, create custom workflow shortcuts for those tedious tasks you do every single day.
And this brilliantly illustrates what can go completely wrong if you aren't careful. There are 3 major pitfalls you need to avoid to make this actually work. First, please don't spend more time tweaking and configuring your AI assistant than actually doing your engineering work. Keep it simple. Second, don't use the assistant for trivial manual tasks. Honestly, if typing a simple terminal command is faster, just type it. And finally, you absolutely must update your project context file weekly. If your AI is working off stale context from a sprint that ended 3 weeks ago, it's going to give you stale, useless answers. You have to be the one controlling the system.
Which leaves us with one final, frankly, critical question to ask yourself today. Are you using AI as a glorified chatbot or as a true engineering partner? Look, the engineers who are really going to thrive in the coming years aren't necessarily the ones who memorize the most complex prompting tricks. They are the ones who build a reliable, repeatable system of workflows and use them consistently. Because in the end, consistency beats sophistication every single time. Start small, build your system, and let the AI handle the mechanical grunt work so you can finally get back to the actual thinking.